start recording. So we are live with tonight's relationships webinar with Jan Borg from Coppell High School. Jan, show is all yours.
Okay, thank you.
Sure.
Like Ish said, I do teach AP Calculus. I have taught just about every math there is in my 30-year career. Going to learn how to teach BC, went to an AP Summer Institute last week. So I finished up 4 years of teaching AP Calc and started using the Casio Prism last year in my classes. Kids loved them. So I'm going to show you something that I did with my calculator and a little bit of inquiry discovery type activity. Our school is really pushing our math department to go beyond just the kind of traditional lecture and kids sit and listen and teachers deliver the knowledge. And so I'm trying to incorporate that as much as I can in my calculus classes and have kids do some exploring before explaining. You may hear me say that a lot tonight because I'm trying to change a little bit the way that I've taught, certainly the way I learned. But with technology as easy as it is nowadays, I think we need to give kids a chance to use it, not just to get an answer, but to explore a concept, maybe make some connections on their own without the teacher having to just deliver all the knowledge. So that's what this activity is. I would have done this activity, or I did this activity, probably after we were pretty good at finding derivatives. We had talked about limits, we had talked about the formal definition of derivatives, and now we were going to look at the relationships among a function, its first derivative and second derivative. And if any of you all teach AP Calculus, this is a huge, huge concept tested on the AP exam. There's going to be graphs in the multiple choice section, there's going to be graphs in the free response section, and typically it's going to be a graph of the derivative, and they're going to expect the kids to be able to answer questions about the function or its second derivative, but usually it's what I call working backwards. And working backwards is always harder than working forwards, but to start the activity we work forwards and then we work backwards. AP is very big on calculators, as you know if you teach an AP class. Straight out of the AP manual it says you're supposed to use technology to help solve problems, experiment, interpret results, and support conclusions. So I think you'll see that that's a lot of what we're going to be doing in this activity. Okay, the first thing that we're going to do, or when I was teaching this activity, and I'll try to go slow on the calculator. I'm not real fast anyway, so remember the on button is right here. And so if you'll just get your calculator turned on, or you can follow me, there's some icons up here at the top. And for the most part, tonight we're going to be working in the graph mode. So I can either hit number 5 and then execute, or since mine's already highlighted on graph, I just hit execute. And so that brings up all of our Y1, Y2, Y3. Also, you might want to notice that under type is where, if you were graphing in other modes, Here's your parametric mode. Here's your polar mode. And then we also have an option of graphing an x-equal, a vertical line mode. And we'll use that later in this activity. Anytime there's an arrow right here, that means there's more options. So if I just press F6, then here's my inequalities. I'm not going to be using those today, but just so you'll know where they are. Okay, so I'm just going to exit. Gets me back to where I was. Exit's a very important button. Menu's an important button. And then execute down here at the bottom is an important button. That was the hardest thing for me to get used to, is just pressing the execute button. So what I would probably do to start this activity, if I was teaching this or starting this idea of comparing the graphs of f, f prime, f double prime, is I might have a quartic function. So there's my x to the 4th power, and then arrow over. And of course I've already thought about what function I want, plus 5x to the 3rd power. And there's several ways, of course, you could do this. You could have the kids graph it, but I think what I would do is I would have the graph showing when they walked in the room, or pretty soon after they walked in the room and we were ready to get started. And what I want to try to get out of them is all the things that they know or should know about a 4th degree equation. But I'm going to take you through a couple of things here to show you how we can get this zoomed in a good viewing window. So remember, you have to press execute, and notice after you press execute that Y1 now is all in blue. So that means you're ready to draw the graph, which is up here. Draw is up here, so that means we're going to hit F6. So a couple things going on. First of all, for some other graph I had zoomed in. So the first thing that I'm going to do is I'm going to go to zoom, which is right here above F2. So if I hit F2, I'm sorry, I don't want to zoom. I want to go to view window, which is F3. So I'm going to hit F3, and I'm just going to go back to the initial viewing window. So if your graph was not zoomed in, not zoomed out, just your initial viewing window, this is what you would see. Now, this is not what I would have showing for the kids. So depending on how you want to teach this activity, let me go through a couple things where we can get a good viewing window. It seems like we need to zoom out, but it also seems like the X values for our window are fine. It's the range of our Y values that we need to change. So we have an option to do that. We're going to go to the zoom window, which is F2. We're going to choose factor setting. And our X factor is 1, and our Y factor is 4. So X factor 1, Y factor 4. And the reason I'm doing that is I know this graph is tall. It's a lot taller than it is I need a lot more y values than I do x values to see all of it. So I like those. I'm going to execute, and now I'm going to zoom out, and that's starting to look better. I'm just going to need to zoom out one more time. And like I said, there's a couple ways you could teach this. You could have the equation showing, and you could ask kids to tell you everything they know before you graph it, or you could have the graph and then have them tell you everything they know. So some of the things that I'm looking for. We can obviously see that it has 4 real roots. We can see that there are 2 local mins, 1 local max. Different books call that, I think our book just says relative max, relative min. Another thing that I think gets skipped over that becomes very important when you're looking at the derivative is kids need to understand where that graph is increasing and where it's decreasing. And from my experience, kids don't know if that means the x or the y values sometimes. So you have to remind kids that you're always moving left to right, so your x values are always increasing. What you want to do is talk about what your y values are doing as you move left to right. So you would talk about the y values are decreasing till you get to that local min, and then the y values start to increase till you get to that local max, and again decrease, and again increase. And those intervals are important. You might also, some kids might remember learning about point of inflection. They might remember learning about concavity. So we are concave up till about right here, concave down till about right there, and then concave up again. So those are all the things that I would expect my kids to know about a 4th degree graph, whether they are looking at the equation, the function, or they're looking at the graph. And you don't want to move on until you've discussed all those things, because they're all going to be important here. Okay, so again, at this point in calculus, you would have talked about how to find the derivative. They would understand the power rule, the product rule, the quotient rule, the chain rule. You would have practiced all those things up to this point. But I spend a lot of time talking about graphs, and it pays off in the end because you know it's going to be tested. Okay, so we've done our little introduction. We've got a good picture. Notice that my y-axis goes all the way to 47, down to negative 47. But my x's just go negative 6 to 6. So that's what that zoom factor did when we changed it at the beginning. All right, so I want to get back to my Y2. Just remember that important button called exit gets you back to the previous screen. If I wanted to go to the main menu, then I would hit menu, but that's not what I want to do here. I just want to get back to this screen where I can type in another graph. Now there's a couple things I can do here. Since kids know how to find the derivative, then you could just have them find the derivative and type it in. But you can also, there's an option button, and one thing I've learned, if you can't find something you're looking for, it's probably under option. So that's another button here that is helpful sometimes. So when I pressed option, these things changed right here. And now I have a calculus button here. So I'm going to go to F2 and I'm going to choose the first derivative. So what happens here, let's talk about this template here for just a minute. It brings up the first derivative symbol, and I want the first derivative of y1. So make sure you use this y right here and not the y down here, not the alpha y. So I'm going to hit y1, and then I have this other thing over here that says x equal and then an open box. There's two things you can do here. When you're in the graphing menu, you can either leave that blank or you can type in x. If you are not in the graphing menu, then what this template, what this function would do is it would find the derivative at a certain x value, and that's that's different than in the graphing menu. So I'm just going to leave it blank. Remember, I have to press execute. It turns everything red. And then I'm going to hit draw. So now we want to talk about what kind of relationships, what kind of, do we notice anything going on between the derivative and the function?
Jan,
And yep.
there is a question.
Yep.
The question is the calculator a computer algebra system? Does it have a CAS?
It is not.
Okay.
It is not a CAS. So in any graphing calculator, we'll graph the derivative like this.
Perfect. Thank you.
Okay, so now we have the blue function, which is our original function. We spent a lot of time talking about that. And now we have the red, which is the graph of the derivative. So we are now going to talk about some important things. And we're going to use our vertical line tool to help us. So from this menu, we're going to hit, we want to open up the sketch menu, which is F4. What I want is not there. So I just arrowed over, and here it is right here, vertical. So what this does is it draws a vertical line for me. And I can move it by just using this left arrow. And what we want the kids to notice is on the original, where I had a local max, it looks like that's where the derivative has a 0, or however you want to say that, a root, an intercept. And so we're going to mark that. The way we mark that is just hit execute. So it leaves that line there. And then I'm going to move over to a local max, and I went a little too far. So I'm going to back up, and it looks like where that local max is. And of course you could be talking about why this is happening, have the kids talk about why this is happening, that tangent line at that local min, that tangent line is going to have a slope of 0. So what your red function is doing now is it's graphing all those slopes. So now you have a y value of 0. And then we could mark the third one here. Some other things that you want to talk about. Remember that increasing, decreasing. So the blue function, remember, was decreasing. That means all those y values are getting smaller. Well, if you look along this blue function right here, and I drew little tiny tangent lines, they would all have negative slopes. So that's why over here on the red, all those y values are below the x-axis. Because remember, you're graphing slopes. So if they're all negative, when the blue function's decreasing, then your slopes are going to be below the x-axis. And then remember here, you started to increase. So what does that mean about your y values? They're all getting bigger. So what's happening to your tangent lines? They all have a positive slope. So that's why over here you see all of these above the x-axis. Now this bothers some kids, why these increase and decrease. And you have to talk about that. And you have to say, well, they're all still positive, and that's the relationship they need to see for right now. And then again, you could do the same thing in this next area. When the blue is decreasing, the red has to be below the x-axis. When the blue is increasing, the red has to be above the x-axis. There's also another obvious relationship that I didn't mention, and that is we started with a quartic, so our derivative should be a cubic, and it is. And they usually get that one pretty easy. Okay, so we've graphed. We've got it in a good viewing window. We've learned how to graph the first derivative. We're basically going to do the same thing now, and we're going to graph the second derivative. So, going to exit, gets me back to that screen. There's a couple things I could do here. Since my vertical lines were already green, it's going to graph Y3 in green, so I might have too much green on there. So I could easily just skip down to Y4 or Y5 or Y6. But I wanted to show you one other thing. I'm going to go ahead and put it in Y3 and then show you how you can change the color, just so you'll know that option's there if you ever need it. Okay, so you might ask the kids, what do I need to do here? Remember that option button to get to our calculus. And we do have a second derivative template. So I could either do the first derivative of y2 or the second derivative of y1. And I'm just going to do that one just to show you that it all works the same. So I'm doing the second derivative. Remember to use this y. And that was y1. Remember, we can leave this box blank on the graphing menu. It actually fills it in for us. If we're not in that menu, we can find a numeric derivative, but we cannot, it will not find the derivative in function form like a CAS system. This calculator is allowed on any test. It's allowed on the SAT, ACT. I'm from Texas. It's allowed on all of our end-of-course exams. It's not like the TI-89, the computer algebraic system. So we need to execute. Remember, it'll all turn the color that it's supposed to be when you're ready to go. Then I'm going to hit draw. And there you have your second derivative. You might want to talk about, it looks like a parabola, which is second degree. So we went fourth degree, third degree, second degree. I would start out with something simple like this before you got into functions that had asymptotes or logarithmic. But you could do all of this with any kind of function. Let the kids discover the relationships. You know, the one they have a hard time with is e to the x, and then when you graph its derivative, it's also e to the x. So this is just another way for them to visually see it. The colors really make everything stand out. Again, I want to use that vertical line tool, but I know it's going to be green, so I'm going to change the color of my second derivative. All right, so to do that, we are going to use the format setting, which is Shift 5. So what will happen here, right now the blue function is blinking. So basically it's asking, do you want to change this one? And also, you know, it's asking about y1 because it says y1 at the top here. No, I don't want that one. So I'm going to hit down arrow. Now the second derivative is blinking. That's still not the one I want. So I hit the down arrow again, and now I think I may have said second derivative. First derivative, now I'm to the second derivative, which is the one I want. So I press execute, and it asks me, do I want to change the line style or the line color? And I'm going to change the line color. So I need to press 2. And I have all these colors to choose from, and I'm going to choose magenta just to make it stand out. So if I press execute and then exit, now I have blue function, red derivative, magenta second derivative. And I could go in there and draw my vertical lines again. This time, I might want to talk about the relationship between, there's lots of things I can do here. I could talk about first derivative, original function and second derivative. So I would want to look at points of inflection. Looks like where there's a point of inflection, something might be going on with the second derivative. Might be a 0 there. We'd want to talk about concavity, where I'm concave up. What's my second derivative doing? It's positive, so it means it's above the x-axis. You could also just, you could turn off any of those functions you want to. You can go back to this screen and you can turn them off. Like say I don't want to see the first derivative. I can just, Ish, do you remember how to turn those off?
Which one was that? The derivatives? Yeah,
Yeah,
simply,
if I just want to turn off one of the functions.
Sure, toggle down to the one you want to turn
See,
off.
I want to turn
and
off
then press
red.
select. Press F1.
Press what?
F1.
Okay. Okay, got it.
That'll
Yeah.
deselect it.
I knew it was something easy.
Yeah, it always is.
So now when I look at my graph, I just want to compare, because sometimes that's just too much. So now I'm just comparing function to second derivative, and they might see the relationships a little better. At the end of class, I would leave this picture up there, or they would have their own calculators. Sometimes we have our calculators out, and sometimes they just watch me on the emulator. And then I have a little summary sheet that I give to the kids that looks a little like this. Can you see that okay, Ish?
Yeah, we can see it.
Okay. This kind of just summarizes the things we talked about. I copy this on the brightest color paper I can find so they won't lose it. And I make a big deal about things like that. And it works at the end of the year. Most of them still had, I think it was bright pink this year. But at the beginning I talked about how big this was on the AP exam, and it's usually not going forwards, it's going backwards. So typically what they'll be given, and you just have to practice it and you have to keep practicing it all year, is you'll be given a graph of the derivative and ask questions about the function. Or it could be second derivative and they ask questions about the first derivative. But those relationships are the same from first and second derivatives, the same as from function to first derivative. So you see in this little sheet here I have a little arrow in the middle, and that means they need to know it going forward and going backward. So for instance, the first one says, remember we talked about this, if our function's increasing, so I'll tell them, think about the blue and think about the part where it was increasing. What does that mean? It means all those y values are getting bigger, so your slope must be positive. So they fill in the blank. The word I would like for them to use is positive, but some of them need to write more than that, and so I tell them to write things like, actually they tell me what they want to write, but things like above the x-axis. And I tell them it doesn't matter if it's increasing and then decreasing, as long as all of it's above the x-axis, that's what we're interested in. So then we just go down the list and we think about the picture. Maybe you have the picture showing. There's lots of ways you could do this, but I always refer back to the blue function, the red function, the green function, or magenta function, and it really seems to help them kind of keep all this straight. So we take some time to fill this sheet in, and then maybe we do one more working forwards, and then probably their assignment would be a couple pretty easy ones where I give them the derivative and ask them some questions about the original. If there's a lot of games out there, little card games where you can do some matching activities where they have to figure out which one's the function, which one's the derivative, which one's the second derivative, and play like a matching type game. I get a lot of ideas like this off of Designated Deriver website. It's all free and people just sharing things. There's a lot of, like I said, card games that you can get and print out and practice this. I find that you have to practice this a lot. This is not easy for kids. But again, if you have them do some exploring first and let them discover the relationships instead of you just telling them, I think it helps. I think it helps in the long run. But you just have to keep spiraling. You have to keep throwing these questions in. I give little pop quizzes that are not really pop quizzes. I tell them when we're having one, and I'll ask them questions all year. You know, if f of x has a max or min, what does f prime have? And you just have to keep hitting it hard, and eventually they get it. And they'll even tell me at the end of the year that, God, I used to think this was hard, and now it's not so bad. So just an idea of an activity that I've used. You certainly could modify it to fit probably any level. Algebra 1, Algebra 2, Pre-Cal. If you're like me, sometimes I have a hard time coming up with ideas, but once I see something, I can usually take it and modify it to fit whatever class I'm teaching at the time. So, I think that's about all that I had planned to talk about. Ish, is there any other questions?
There was a couple of questions on when you went into the, let's see, a couple of people asked about the tangent function, and was wondering how that works. I don't know if you want to show them a quick demo of how the tangent function works.
You mean draw the little tangent lines?
Yeah, because a couple of people saw that jump by when you were on that screen and were like, hey, there's a tangent one on there.
Now, which screen was I on? Because I'm not. Do you remember?
Yes, I think you are in the sketch
Was
mode.
it under
sketch?
Okay, let me see if I can get to it.
There you go.
This one?
Yep.
Oh yeah, it'll draw the tangent line. I would probably I would use this activity, the little tangent lines, before this, where we would have talked about you can move that tangent line around. You see how it's moving around? So like when you get to a local max or local min, oops, they can see that tangent line is horizontal, so can't get it exactly there. But that's what that does. We actually have another activity in our calculus guidebook where we do use that tangent line a lot, just to get them to see that, you know, as you move along that curve, that slope changes, which is what the derivative is.
Right. Yeah, the only other question that we had was the handout that we will make that available to participants. We'll send an email out since we do have your email.
Okay.
So we'll send that handout to everybody who participated in tonight's webinar.
All right. Again, I just copy that on bright paper and tell them not to lose it, and it seems to really work when they can have that right there in front of them and get those relationships kind of, you know, memorized. hopefully not just memorize, that they conceptually understand it. But I'm always surprised that this is kind of a difficult concept for them. So I really thought that last year went well when I introduced it this way.
All right. Well, thanks for hosting tonight's webinar. I hope everybody got what they wanted. Thank you for all the questions and all the side panel stuff going on. So thanks again, Jan.
Okay, thank you.
All right. Take care.
See ya.